Yeah, good afternoon. My name is Si Nguyen. I'm Senior Director for Product Line Management at Altiostar. And today we'll talk a little about our open vRAN solution and how we're also leveraging KONTRON's servers for such an implementation. So Altiostar is, a open a vRAN supplier in the market. We're one of the pioneers in this area. So just want to, touch a little bit on what is vRAN. So vRAN is basically running the base station functions. The functions can be split into multiple functions and running that as virtual functions on commercially off-the-shelf general purpose hardware. So in our implementation, we have two main functions, the VCU and the VDU. Very similar to what 3GPP has defined, VU and CU. They are virtualized, and then on one side we run it as OpenStack VNF functions on OpenStack infrastructure, and then on the other side we also run it as virtual function, but on a different set of hardware because the requirements there are slightly different in terms of the real-time requirements and the density of the processing that is needed to run those functions. So basically, what are the benefits of running the base station as a virtual function? One is very very easy and fast to deploy. It's just a software deployment and minimal physical hardware installation. Another is CapEx because of the pooling efficiency that you can get from running virtual functions. Energy saving comes from the pooling efficiency as well because you have less hardware to provision, so you get better, better energy usage. Operational efficiency, you virtualize, you centralize a lot of the functions, so you can go and manage it in one place instead of having to go to every site whenever there's a hardware failure or something like that. So it's operational efficiency is a big benefit. And network availability, with virtualization, you have this, inherent redundancy. Like when a piece of hardware fails, the infrastructure is smart enough to detect it and automatically reinstantiate the function on a different piece of hardware. So you have a much more highly available network. The system might go down for a minute, or a coverage may go down for a minute or so, and then it come back up. Versus today, when you have to distribute everything at the site, when a hardware fail, you then end up have to send people out there. Could take hours, days, sometime if it's far away. So much more, available for the network. So what we did with vRAN was that we separated the software implementation from the hardware, and allow for operator to buy hardware from anybody, such as yourself, KONTRON, and the software would come from us, right? So with Open vRAN, we took that idea a step further, and instead of just using the radio that we provide, we open up the interfaces to the radio as well, to allow for third-party radios to also provide the radio for the operators. So today we basically interface based on our standardized protocols, because there's no industry specification on the interfaces that we have so far. So we basically implement them based on our standardized protocol. We open up that protocol specs for third-party radio. But in the future, we will implement the standardized solution. There's a couple interfaces, the HLS or higher layer split interface, which is what 3GPP is developing now. And then there's also a lower layer split interface where you split the at a lower protocol level. We'll be able to support both of those. So the higher layer interface, you have most of the DU function that I showed before integrated inside that radio. A radio vendor can come with all those functions already implemented and just integrate with us on that higher layer split interface. or for a lower layer split interface, they would implement just the lower function in the radio, and then we would then integrate with that radio through that interface. There's a couple ways to do that. One is to integrate a reference design of the DU platform inside the radio itself. So we would also provide a reference design for the DU function, the DU platform that the radio manufacturer can integrate directly inside the radio, and then we interface through the lower layer split protocol. Or we just run the DU external, and then we integrate between the radio and the DU through that lower layer split function. Today, it's mainly CIPRI that we're integrating with, but in the future, whatever 3GP defines as a lower layer split. So what are the benefits there? So basically opening up the whole supply chain, right, for more competitiveness, and allowing operator to use the best of breed solution from the different radio suppliers. Operator can also buy the radio directly from the radio supplier, so cut out the middleman, reduce the cost by cutting out the margin that the middleman usually mark up, and also just open up the whole ecosystem, so there's no dependency on a single vendor to provide everything, and be at the mercy of their innovation versus using the best of breed, right? So for Altiostar, our solution is now today based on third-party solution, third-party hardware mainly, and our software. In the future, we can also mix and match software as well, through those open interfaces, and that's also a very possible scenario in the future. But what we have today is massive MIMO AES solution, macro, micro, pico, DAS solution, and all those come from our third-party partnership that we have been developing, as well as some of the solution coming in-house, because we started with in-house solution and then opened it up for third-party to supply this as well. And then servers, as you know, they already are off the shelf. So for virtual infrastructure that run the VCU, they're typically data center servers, rack servers, or place server that comes from the like of HP, Dell, Cisco's, and them. And then for this VCU, for VDU function, we get there's two different type of server. There's the one U server that you can put at the site directly, and that needs to be more extended temperature coverage and things like that. So there we have your partners like yourself, KONTRON, that make those solutions for us. And then also there's a solution that goes in a central office, but near the site, so some level of aggregation. And again, KONTRON also have solution in that space as well. So that's where opening things up, separating hardware and software, allow players like yourself to be able to take advantage of the business. Okay. And on the software front, so we have LTE software today. We are evolving the software, developing 5G support on those software. By the way, all the radios that we deploy today are 5G upgradable, software upgradable, so they're hardware ready to go 5G upgrade. We also mobile edge computing function integrated in our radio and our software. Analytics for the network, self-organized network functions, those we also have. Virtual EPC functions, we work through partners. So we have a complete end-to-end solution through partnership on the software front as well. NFV infrastructure, again, is also a partnership from our our partners. And we also, now also working on customization of software for operators as well. So it's a customization software as a service to the operators. And then on the services front, to complete the whole support and deployment, the solution, end-to-end solution, plus the deployment and the turnkey system build up for operators. We also offer services to our partners. So services such as RF planning, installation, commissioning, optimization. So all those services are also available to us with our partners. Just to conclude, so we have been, recognized for pioneering the vRAN solution in the industry. Last year, we received 2 awards. One is the Best Mobile Technology Breakthrough Awards, and the second one is a very, high accolade in terms of outstanding overall mobile technology that was selected by a group of 20 plus CTO in the operator space. So it's a very good acknowledgement of our contribution in this space. So any questions? Yeah? All right. Thank you.